Okay, so what we're doing today is section 2.5, compound inequalities, part 1. We've split it into 2 parts so that way you can get a handle of what the graph looks like before we have to solve. Okay, so a compound inequality consists of 2 distinct inequalities joined by the word and or the word or. To find a solution of a compound inequality, you graph them on the same number line. Okay, so or means it can be one answer or the other one. And so at -2, this is going to be an open circle. Let's draw the circle better. And it gets smaller, so it goes to the left. And at +3, it's a closed circle, and it's greater than, so it goes to the right. So ORs is a union because it's one or the other way. So ORs, majority of the time, are going to go to the left and to the right. So it's anywhere you see an answer, that's what your answer is. All right, for an and, this is where they intersect. So this is the intersection. So this one I'm going to do a little differently. Okay, so at -3, it's a open circle, or I'm sorry, closed circle, and it goes to the right. Now I'm not going to draw a thick line yet. I'm just going to do different colors. So there's the first one. And let's go green for the next one. And then at 1, it's an open circle, and it goes to the left. For intersections, your answer is where they overlap. So my actual answer, now I'm going to do in blue, and I'll do it above, is from -3 to 1, and it looks like a dumbbell. So this is where they overlap. You don't actually graph both of them. I graphed both of them for this example, so you see what happens. We actually just have a dumbbell. And so intersections are usually going to come together. Okay? Sometimes an intersection is written as one inequality. So what happens is I put the smaller number on the left, and x is greater than that number, but it's smaller than 1. So you put this smaller number on the left. Remember to do that. Okay? All right, and so now what we're going to do is we're going to try and write some equations for it. So this is an and so at -1, it goes to the right. So I always put my x on the left. And so x at -1, you see this -1, it goes to the right. So it's greater than, and because it's closed, it's underlined. And now I look at this other one, x with 5. At 5, it goes to the left. So it's less than or equal to. I'd also like you to write it as 1 together. And so remember, with 1 together, you start with the smallest number, x, and then the biggest number. Well, x is greater than the -1, but it's smaller than 5. And if you put the smaller number on the left, it always shows you that it points to the left. So that's a good way to remember it. Okay, so for this one's an or. And so I'm going to compare x with -4 or x with 0. At -4, it goes to the left, so that's a less than. And at 0, it goes to the right, and it's a closed circle at 0, so it's greater than or equal to. Okay, I would like you guys to try these next 2 on your own and see how you do. Once you have it, go ahead and press play. Okay, so you should have recognized that this is an and so I have to compare x with -2 and x with +2. At -2, it goes to the right, so it's greater than, and it's an open circle, so it's not underlined. And then at +2, it goes to the left, so it's a less than. And then when we write them combined, remember you put the smaller number on the left, then the x, and then the bigger number. And they're going to point to the left because x is greater than -2, but it is smaller than +2. All right, so this one you should have hopefully recognized this is an or. So I have to compare x with 0 or x with 5. And so at the 0, it goes to the left. And at the 5, it goes to the right. And that's it. Okay, so let's try these. We're going to have a 0, 4, -4. Okay, and so at -4, it's an open circle, and it's to the left because x is smaller. And then at 0, it's an open circle, and it's to the right because x is bigger. And that's correct because it's an OR problem, and OR is supposed to go left or right. Okay, over here, here's another OR problem. So there's, we don't need to have all of them, but we'll do this. So x is greater than -2, so open circle to the right, or x is less than -3, open circle to the left. Okay, so for here, this is one that's condensed, and so it's -2. So this one should be a dumbbell because this is an and problem, so it should look like this, something like that. Okay, so at -2, it's an open circle, and x, you see this? It says x is bigger than it, so it's going to go to the right. And then at 5, it's a closed circle, and x is smaller than it, so it does make a dumbbell. They are, that's where they intersect. All right, here's one that's separate. And so at -4, it should go to the right. And at 2, it goes to the left. So that also makes a dumbbell. Okay? So remember to do one thing at a time. Union, an OR problem is a union, which goes left or right. And you could think of it, sometimes I say one way or the other. Remember that song? And so you can think about it that way. And intersection is when they come together.